Hello dear students, welcome to BYJU'S exam prep. So guys, today our session is based upon how to find out the internal static indeterminacy for a 3D rigid jointed structure. I think all of you know that guys, there is one basic method to find out the DSI value in case of rigid jointed structure like your member method, cut method and closed loop method, right? But today guys, I will tell you about the how to find out the DSI value by using cut method, right? What is cut method? I will explain in detail and you will get your answer quickly, right? And I will show you one trick guys also how to calculate the number of cuts easily in case of 3D structure. Okay, so let's begin this particular session guys, and those who are watching this video as a first time, let me introduce myself. My name is Krishna Yadav and I am teaching from last 9 years guys, and I have done my masters from IIT Roorkee. I mentored almost 20,000 plus students for the various examination like GATE and ESC, and generally these are the subjects in which I deal, which is basically environment, structure, RCC and engineering mechanics. So guys, before understanding this concept, we need to understand what is basically DSI or what is basically internal static indeterminacy. So if we define it, it is very easy to define. It is nothing as it is the total number of unknown internal reaction which are present in any structure. So what are the total number of reaction is present in case of any type of structure, whether it is rigid jointed structure or pin jointed structure, that is nothing as that is your DSI value. Now the question is, sir, how we can find it out in case of 3D rigid jointed structure? Please tell us. So listen guys, basically there are three methods. Let me introduce it. There are three approaches by which you can solve the problem. One is your simple, which is nothing as member and joint method, or by counting the member and joints. So with the help of member and joints, you are able to find out what is the value of DSI, right? With the help of counting the members and joints, you are able to find out what is the value of DSI in a 3D rigid jointed structure. Second approach which you can use guys, that is basically closed loop method, right? Closed loop method, and I think all of you know these two methods, right? Generally, what is member and joint counting and how we can calculate the closed loop. But I will tell you a third method which is a different method guys, and it is easy among all three, right? So that is nothing as that is basically cut method, right? Cut approach. Cut approach. If you are able to understand how we can calculate or how many cuts are present in a 3D structure to make it open, then you will get your answer as quick as possible. And I will tell you the trick also. Okay. Now listen guys. First we will define what is open structure, and then we will define what is closed structure. Then only we can understand how to make a structure open by cutting it. Okay. Then only you can understand that concept. Otherwise it is not possible. So listen guys, first we will discuss what is open structure and what is closed structure in general. Let us suppose this is a single bay portal frame which I have, and let us consider if you mark any 2 points on the structure. Let us suppose this is one of the point 1, and this is another point 2. Now let us consider guys, if I want to move from point number 1 to point number 2, I need to follow this particular path. So can I say that guys, this is basically path 1. This is nothing as path 1. Now let us suppose guys, if I want to come back to the point 1 from point 2, I need to follow the same path because I don't have any other option in this case, right? So you can see guys, I need to follow the same path to reach to the point number 1. That means, can I say that guys, in this particular structure, if you take any 2 points on any place on the structure itself, so the path which you have to follow from point number 1 to point number 2 is same as to move from point number 2 to point number 1. That means path number 1 and path number 2 are same, right? If such condition is valid in any structure, then that particular structure is a open structure. Now path 1 and path 2 are same. That's why it is a open structure. Now if you talk about the closed structure, what is closed structure, sir? It is very simple. Let us suppose guys, if we take another building frame over here, and it is a multi-level building frame, right? And again, we will consider 2 points over here. Let us suppose this is point number 1 and this is point number 2, right? Now, let us suppose, guys, if I ask you, if I want to move from point number 1 to point number 2, how I can move it? So, guys, it is very simple. From this particular point 1 to point 2, you have one path, or you can say that this is path number 1. Path number 1. And if we talk about another path, guys, we have another path also, which is nothing as point 2 to point 1, like this. So you can follow this particular path to reach point 1. So guys, can I say that in this particular type of structure, which is nothing as a closed structure, if you want to move from point 1 to point 2, you have two different paths over here, or you can say that you may have multiple paths, right? So without retracing the same path, I can move to the point number 1 again, right? That means our path number 1 and path number 2 are different, and that's why this structure is a closed structure. Clear? In this case, path 1 and path 2 are different. That's why it is a closed structure. That's why it is a closed structure. Crystal clear to all of you? Now I think you are able to understand what is open, what is closed. Okay. Now if I ask you guys, if I want to make this closed structure in terms of open, how I can do it? I need to cut one of the path, or I need to cut one of the members so that it can become open. So guys, if I cut this particular member, then ultimately this closed structure will become open. Getting my point? If you cut this particular member, then this particular structure, which is this is one, guys, right? This one become a open structure. Let me show you that, guys, with drawing it so that you can understand in detail. Let us suppose this is a closed structure, and you know that in this case we have multiple paths to move from point number 1 to point number 2. If I cut this particular member at this location, so you can understand, guys, now I will have only a single path to move from point number 1 to point number 2, or point number 2 to point number 1. Now the structure has open. Now tell me, guys, right now how many cuts you have put it in this particular structure to make it open? 1. So can I write here, guys, it is nothing as our C dash, which is 1. What is C dash? Let me write it down. It is basically minimum number of cuts which is required to make structure open, right? If you want to make a structure open, then how many minimum number of cuts are required? That is nothing as, that is our C dash. Okay. Now tell me, guys, in case of 2D rigid jointed structure, we know that, guys, basically there are 3 internal reactions which are present, correct? So you can see here, guys, if I draw 3 internal reaction, one is shear force, second is axial force, and the third one is bending moment, right? So generally in case of 2D rigid jointed structure, we have 3 internal reaction. But if we talk about 3D structure, tell me, guys, how many internal reaction are present in case of 3D rigid jointed structure? You know that, guys, in this particular case we have 6 internal reaction. We have 6 internal reaction. Let us suppose if I break the structure at this location, you may get 6 internal reaction over here. 6 internal reaction, right? So at a single cut, how many reaction you are trying to cut over here? Basically 6. So can I say that, guys, the value of DSI is nothing as, it is basically 6C dash. How we have written it, I will explain. So at every cut, let me write it down. On a single cut, 6 internal reaction are unknown. 6 internal reaction are unknown, right? If you cut a structure which is a 3D rigid jointed structure, so if you cut a member, guys, so there are 6 internal reaction which are unknown to us. right. But if we talk about, guys, if we have c dash number of cuts which is required to make a structure open, then what should be the value of DSI? It is nothing as 6 into c dash. 6 into c dash. And why it is so? Because the open structure are always internally determinate in nature. So guys, you need to understand what are the minimum number of reaction which I should remove from the structure, or I should cut in the structure, so that the structure will become internally determinate. So guys, you will get your answer, which is nothing as DSI value, which is nothing as your static internal indeterminacy, that is 6c dash in this particular case. Understood? Let's take some example so that you can understand it quickly. Let us suppose, guys, this is our 3D rigid jointed structure. 3D rigid jointed structure. Okay. Now tell me, right now you need to cut, or you need to put a cut over here, guys, so that the structure will become open, right? So let me tell you what is that trick basically. So guys, right now it is very simple to know how many cuts we require in this case. So we will cut at this particular location. Now you can see here, guys, how many cut we have put it? Only one. So can I write it? C dash is equal to 1. So what is the value of DSI in this case? DSI is equal to 6 into 1. That is equal to how much? It is equal to 6. Very easy. But guys, this particular process will become difficult when you have multi-story building. Okay, let me show you that. Now let's take another example. Then after that you are able to understand it 100%. Okay. Let us suppose, guys, this is our structure, right? And now you need to calculate how many cuts are required to make a structure open. Now it is very difficult to count the number of cuts in this case. So let me tell you, guys, how we can do it very quickly. Okay, so first what you need to do, guys, first try to cut the front two member, right? If you cut front two member, how many cut we have put it? 2. Okay, so you can see here, guys, I can cut the member this, and I can cut this particular member also. Okay, so 2 cut we have done. Okay, now after that, guys, you need to pick this 2 member and try to open the structure on a 2D plane, right? So it look like this. If you open it, the structure is to be like this. The structure is to be like this. Yes or no? Yes, sir. Now tell me, guys, right now how many cuts we have done? 1 and 2 only. Now tell me, guys, if I cut this particular member, then this portion will become open. If I cut this member, this portion will become open. If I cut this member, this portion will become open. So how many cut we have done over here? 1, 2, 3. So total number of cut is equal to how much? It is equal to 5. Now tell me, guys, what is the value of DSI? It is nothing as, it is 6 into C dash. That is 6 into 5. It is equal to how much? 30. So 30 is the internal static indeterminacy of the 3D rigid jointed structure which is given to us in the problem. Getting my point? Very simple. Very simple. Okay, let me ask you one more question, guys. Let me ask you one more question. Let us suppose again we have one building frame which is to be like this. Which is to be like this. Now again you need to calculate what is the value of DSI. What is the value of DSI? This is the question, right? Another type of building frame. How you can do it? Again, it is very simple. First, you need to cut the front two member. So guys, you can cut this particular member, you can cut this member, you can cut this member and this member also. So how many cut we have done? 1, 2, 3 and 4. Now again, you need to open the structure on a plane. Okay, let's do it. So if you open the structure, then it look like this. If you open the structure, then it look like this. 1, 2, 3, then 4, 5, and a part of the structure is to be like this, right? which we are not trying to open on a plane because it is not possible to draw it on a plane, right, for this particular part. But now I think you are able to understand it. So how many cut we have done? 1, 2, 3, 4. 4 cuts are done. Now guys, rest of the cut is how much? Right? 1, 2, 3, 4, 5, 6, 7, 8. Right? And this one, right? 9. So total number of cuts which is required over here, guys, 9. Let me count it again. 1, 2, 3, 4, 5, 6, 7, 8, and this one is 9. So C dash is equal to how much? 9. So ultimately the value of DSI is equal to how much? 6 into 9, it is equal to how much? It is equal to 54. Now you can check this particular answer which we have got by using this particular concept, by using the member process also, or by using your closed loop, right? And tell me guys whether you are able to get the answer or not quickly by using this particular process. So I hope all of you are able to understand this concept, which is a very easy one to solve the problem of 3D rigid jointed structure, right? And to find out the internal static indeterminacy for that. Clear? So let's close this particular session, guys, and we will meet again in such type of session, which is basically the capsule course. Okay, bye bye guys, take care. Thank you so much for joining the session.